Welcome to Chapter 5. Chapter 5 is on measuring variables, which is kind of the next step in our research project. You have your two variables identified from your hypothesis, and they are continuous variables since we're going to be doing a correlational study. And so this chapter is going to talk about the different ways in which we can measure variables in our hypothesis. And essentially, what we have to do to measure variables is ask participants questions in a lot of cases. And so that's going to be the main focus of chapter 5 is how can we ask the right questions to appropriately and accurately ask questions to measure our variables. And so the way that we word a question can really influence how a person responds to it. We can lead them to a certain answer. We can kind of bias them in one direction by how we formulate a question. And so what we have to do is ask questions in a way that's not too vague, but it's also not too specific that we're kind of leading them. So there are two broad categories of questions that we use when we're measuring variables in research. And so they are quantitative and qualitative. And quantitative questions, they ask people a question or have people respond to a statement in a way that is numerical, so using numbers. And this provides us with data that's really easy to analyze. And then the other category of question is qualitative. And qualitative asks questions in a way where people respond with words. And so what that does is it provides us a richness of information. We may get some responses that we weren't expecting and that we otherwise wouldn't have uncovered if we were doing quantitative research. So there's a richness of information there, but qualitative research is a little bit harder to analyze in terms of data than quantitative because you're working with words and they can be more subjective or vague, whereas numbers are just straight up numbers, pretty straightforward. So we're going to talk more about these two categories of questions and about measuring variables. So let's dive in. Okay, so the first type of questions that we're going to discuss for measuring variables are called fixed alternative questions. And so these are questions where the respondent selects his or her answer from a set of specified responses. And so the simplest type of fixed alternative question is just a simple dichotomous yes or no. And this is fine when the question only has these possible response options. For example, are you a student? Can only be responded to with either yes or no. And so multiple choice questions are the type you would use if there's more than one possible answer. So if yes or no won't suffice. For example, you could use age ranges as fixed alternative questions where you give people, say, 17 to 25 as an age range, 26 to 35, 36 to 45, or 46 and above, and then the respondent has to select one of those answers. So, of course, no type of question is truly perfect. And so, with a fixed alternative question, the problem is that you might not include an option that the respondent would choose. So, for example, if you ask the question, why did you give your baby up for adoption? And you give three options for an answer: A, peer pressure from church, B, peer pressure from family, or C, peer pressure from baby's father. Maybe none of these are the right answer for the person. And so the solution to this is to include an other option and have the respondent write in their answer. That way they're not forced to choose an answer that isn't true for them. So one way to avoid that problem altogether is to use open-ended questions. So open-ended questions, unlike fixed alternative questions, allow the respondents to answer questions in their own words. So like we discussed on the previous slide, this is sort of the problem with fixed alternative questions is that they don't allow people to answer questions in their own words. Instead, they provide answers for people, but those answers might not be true for everyone. There might be another reason not mentioned on the fixed alternative question survey that better explains their experience or their situation. So Open-ended questions avoid this problem altogether by just letting the respondents say whatever they want to say. So, the good thing about these open ended questions is that maybe as researchers, there are elements to the behavior that we're studying that we were unaware of. And so, when people are allowed to just write whatever they want to answer our survey questions, it gives us a lot more detailed information and may even lead us to develop another variable to add into our study that we hadn't considered before, or ask another set of questions to measure our variable that we hadn't considered before. So, open ended questions are cool because we can ask really broad questions like, what do you like about your college? And then we really open up ourselves to a wide variety of responses there. So, we can get a lot of good and detailed information asking these open ended questions. However, analyzing the data that we get is a little bit more difficult than when we have quantitative research, a little more time consuming, more open to subjectivity and bias. And so, those are all kind of the problematic aspects of open ended questions. But what we do when we collect data using open ended questions and we have, just kind of a bunch of words from a bunch of different participants is something called content analysis. And the way you go about conducting content analysis on your qualitative data is you first categorize responses into reoccurring themes. So, I have an activity that I do with students sometimes that has them use content analysis on songs. So, the first step is I have them think of a bunch of different themes that are sung about or written about in songs. For example, partying or breakups. And then once they choose the theme, so let's say they choose partying, then what I have them do is look up the lyrics to a couple songs on partying. So generally, they choose 3 songs that are about partying and they look up the lyrics for those 3 songs. Then, what I have them do is go through the lyrics of all 3 songs and look for common themes. And so, maybe a common theme for partying is alcohol, for example. And so, they might write down that the themes they're going to look for is every time a song lyric mentions alcohol. That is one of the, I guess at this point, it's kind of a sub theme of partying, right? And then maybe another one is going to be being so messed up from partying, anything about being so messed up, so drunk, throwing up, anything like that will be your next sub theme. Maybe the third sub theme is anything about dancing the night away, or twerking, or whatever would be our third sub theme of partying. And so then what they do is they go through each song lyric and they count the number of times that they see a reference to alcohol. They count the number of times they see a reference to being messed up, sick from alcohol, and then they count anytime they see people talking about dancing, as their third sub theme of partying. And so when they do this activity in class, what they really learn from it is how long it takes to complete a content analysis, and also how difficult it is. One person might clearly put in their lyrics, like the Lil Jon song, shots, 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 shots. And so you're counting each reference to shots as a reference to partying, where another person, might have kind of a thinly veiled metaphor for alcohol that they're using in their song. And so it's a little bit harder to know if you should count that as a sub theme of partying or not. So content analysis is a little bit tricky, it's certainly time consuming, but we do get a lot of great data from open ended and qualitative questions. It's just kind of a pain to analyze it. Okay, so the next way to measure variables is to create what are called rating scales, which I'm sure you've seen before. And rating scales are essentially fixed alternative questions where we ask the respondent to indicate magnitude on a scale. So you may have gone to the doctor and they have given you this pain scale where you're asked to indicate how much pain you're in on a scale of 1 to 10. So, this researcher that I follow on Twitter, she had to take her husband to the hospital and she saw this pain scale on the wall and it frustrated her because she felt like it wasn't really a good measure. Um, and so, as a researcher, she spent the rest of the time in the hospital creating her own scale for measuring pain. And here is that scale. So, rating scales are generally considered closed ended questions in opposition of those open ended questions that we talked about on the previous slide. There are all different types of rating scales. Essentially, what makes them different is the number of options the person has to choose when responding. So, the number of response options, and then also the way those response options are labeled. So, usually, rating scales involve a question that's followed by a scale with adjectives. And those adjectives can be whatever you want, but they have to constitute a scale. So, increasing and decreasing in magnitude. And a scale can have as many response items as the researcher wants. However, it can get a little bit confusing for the respondent if there's like 20 different options on the scale. So generally, we try to keep it pretty simple, like 7 response items to 10 max. So the next way to measure our variables that we're going to discuss is something called a Likert scale. So a gentleman by the name of Rensis Likert, who was alive from 1903 to 1981, invented this method in 1932 as an attempt to more accurately measure participants' attitudes. And still today we use this. It's one of the most popular methods of measuring variables, especially in psychology research. And it's one of the easiest ways to quantify an attitude or an opinion. So, in other words, to turn an attitude or opinion into a number so that you can do math on it. Because in science, there is a quantitative expectation, you got to do math. So, a Likert scale is a scale where the items are a statement. They're not a question, but it's a sentence. And then the respondents are asked to what degree they agree or disagree with that statement. And then the scale itself usually has 5, 7, or 9 response options. So if you look on your screen at the slide, you see a response scale with 5 options. So the anchors are strongly agree and strongly disagree. And the anchors are the two labels at the ends of the scale. Either way, whether you have 5, 7, or 9 response options, a Likert scale requires the use of a neutral or NA option in the middle of the scale, like you see here on the slide. And this gives the respondent kind of the ability to like opt out of an item. Like, I just don't really have any response to this, or I don't feel one way or the other about it. So when we use the survey method and give our participants these questionnaires, there are some things that we need to look out for. And those things are called socially desirable responses and a response set. And so a socially desirable response is where people may respond to your question that's measuring your variable in the way they think is appropriate but is not necessarily true for them. So, in other words, it's kind of a form of impression management. They want to respond in the way that maybe puts them in the best light rather than the way that is actually true, or the way they, what they perceive to be the best light, rather than the actual true behavior or attitude or opinion that they hold. Another problem that we sometimes see with respondents on surveys is that they engage in what is called a response set, or they give us a response set. And a response set is just always agreeing, always disagreeing, or always being neutral. So essentially, they're just picking one response and they're responding that way on every single item. Generally, we get a response set when a participant has become what we call acquiescent. In other words, they've gotten bored and they're just like conceding, like, fine, I'll take your survey, and they're just click, 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 click. But they're not necessarily even reading the items, or maybe they do read the items, but they don't think about what they mean and kind of incorporate them into their lives before they respond. And so the answers that we are getting are not truthful. So there are some solutions to dealing with socially desirable answers and response sets. The first of which is called reverse coding. So reverse coding is a way to alter the wording on your items so that on some of those items an attitude is reflected by agreeing, and then on other items that same attitude is reflected by disagreeing. So, for example, if you look on your slide here, you see items 1 and 2. And 1 says the Chargers are the best team. And a 5 would mean that you strongly agree with that statement. So, you're a Charger fan if you put 5. And then the second item says there are teams that are better than the Chargers. So if you put a 5 on this, it would kind of be weird, right? It would contradict what you had said on number 1. And this might give us, as the researchers, an indication that you're not actually reading the items, that you've become acquiescent, and that you're just giving us a response set. So we use these reverse coded items to kind of catch people, and to make sure that their answers are consistent, and not, dishonest or not, a result of them not even reading the items themselves. And then another solution that we can do is include something called irrelevant items. And this will help us to avoid those socially desirable responses a little bit. They help us to hide the purpose of our survey. So people are naturally inquisitive and they want to try to figure out what it is that the researcher is studying when they are given a survey. And so, in order to kind of combat that, what we do is we create these irrelevant items that kind of throw them off. They're a little bit off topic, and so it might help to kind of conceal the true purpose of the survey. So, if I was doing a survey and I wanted to know how people felt about the Chargers, and then I included an item about spaghetti, it might make the person taking the survey go, wait a second, maybe this isn't about the Chargers. What do they want to know about spaghetti? Does spaghetti have something to do with the Chargers? Right? And so they get all confused. And then hopefully they'll just focus on answering the questions honestly rather than trying to figure out what it is that we're studying. And then the last solution to people being dishonest on surveys, is to just really reinforce anonymity. So you want to make sure that the respondents know that they are not going to be identified at any point. We're not going to collect identifying information. We're not going to look for identifying information. So we just need to really reassure our participants, at the outset of our study, that there is no way we will know whose response goes with what person because their responses are completely anonymous. Okay, so another way to measure variables, outside of doing like a survey, for example, is to observe people's behavior. And when you observe people's behaviors, there are many different ways to measure that behavior that you've observed. So, one way you can approach measuring, observable behavior is with accuracy. And this is when you measure to see, if somebody is doing something right or wrong. Are they accurate or are they inaccurate? So, for example, if I wanted to create a test to test somebody's knowledge on empathy, I could give them a bunch of questions that ask about empathy, and then depending on the number of questions they got correct, I would have an understanding of their understanding of empathy. And so accuracy would be measuring how many questions they got right. And then the next way to measure observable behavior is with frequency. And so when you measure frequency, you're just measuring how often a behavior occurs in like a set amount of time or a specific amount of times. So for example, I could measure how many times Joe goes to the bar and orders a drink in an evening. And each time I observed Joe going to the bar and ordering a drink, I would just make a tally mark on a piece of paper. And then I would add up all those tally marks, and that would constitute a frequency measurement. And the next type of measurement for observable behavior is latency. So you can measure how long it takes someone to engage in a behavior. This is essentially just a measurement of reaction time. So when I do an activity in class to help students understand latency, I take them to this website, or I get them to access this website, that measures their reaction time. And what they have to do is, watch kind of a virtual car driving down a street, and then when they see a stop sign pop up, they have to press the space bar as fast as they can. And depending on how quick they press the space bar, the computer will spit back an age at them in terms of their reaction time. So it will say your reaction time matched that of a 40-year-old's reaction time. And so what that website is doing is measuring the latency between when the person sees the stop sign and when they press that space bar. Another way to measure observable behavior is duration. So you can measure how long a behavior lasts for. So I could, as a statistics instructor, I could measure how long it takes each student to complete a statistics quiz, and I would be measuring the duration. And then finally, there's amplitude, and this is the size of a response. So how loud did someone scream when we scare them, for example, would be a measure of amplitude. So the way that you measure your variable is going to determine the kind of variable that you have. And the kind of variable that you have is going to determine the statistical analysis that you run. You probably remember from statistics that there are certain statistical analyses that can be run on certain types of variables and not run on other types of variables. And so we are going to review the different types of variables now, or the different levels of measurement. So the first level of measurement we're going to discuss is nominal, and nominal variables are also referred to as categorical variables. They are qualitative in nature, meaning that the data you collect on categorical variables or on nominal variables are going to be data that is collected in the form of words. So if you were to ask someone what their gender was, they would respond to you in a word rather than a number. If you were to ask someone their eye color, they would say brown, blue, green. And again, those are words. They are not numbers. So the key thing to remember about nominal data is it's data collected in words or categories or types, not numbers. So the next level of measurement that we're going to talk about is ordinal, and ordinal is rank ordered data. The intervals between the values are not necessarily equal. They are not equal intervals, and so they fall into categorical variables just like nominal does. And so a rank order could be first place, second place, third place. It could be the highest degree that a person has. But let's say that they're rankings. And if the data are rankings, the difference between a person that gets first place and second place is not necessarily the same distance between the person that got second place and third place. So let's say that there were people running a race, and the person who ended the race in first place ran the race in 1 minute. The person who ended in second place ran the race in 1 minute and 1 second. And the person that ended in third place ran the race in 15 minutes. So the difference between first place and second place was 1 second, and the difference between second place and third place was almost 15 minutes. So that's what we mean by not equal intervals. And the next level of measurement that we have is no longer categorical or qualitative. That was for nominal and ordinal. But now we're moving into quantitative, so numerical data. So the first type of quantitative data we're going to talk about is interval. And so interval as a level of measurement is where the intervals between the values are equal. And so this could be things like temperature, dates, age, weight, where the difference between 1 pound and 2 pound is 16 ounces, and the difference between 2 pounds and 3 pounds is 16 ounces. So with interval data, we do have equal intervals between the numbers. Also, interval data has an arbitrary zero, meaning that interval data can be negative numbers. Like with temperature, for example, you can have the temperature be below 0. It could be negative 30 degrees, negative 10 degrees, or a bank account, for example, could be below 0. You can have a negative balance. And interval data is referred to as continuous because theoretically it could just continue on forever. Like if I were to ask you, how long can a human being live for? What's the absolute longest a human being could live for? You can't give me an absolute answer to that because we don't know for sure yet. We can tell you how long the eldest person has lived, but that doesn't tell us the potential. So that's a continuous variable. And then we have ratio, which are like intervals, but the only difference is that they have an absolute zero. So ratio variables cannot be negative. We start measuring from zero. These are things like height, weight, age, length. Those variables cannot be negative. Okay, so let's watch this video on levels of measurement just to make sure we really have a clear understanding of the concept.
Levels of measurement. These can be split into two groups, qualitative and quantitative data. They are very intuitive, so don't worry. Qualitative data can be nominal or ordinal. Nominal values are like the categories we talked about just now. Mercedes, BMW, or Audi, or like the four seasons, winter, spring, summer, and autumn. They aren't numbers and cannot be put in any order. Ordinal data, on the other hand, consists of groups and categories, but follows a strict order. Imagine you have been asked to rate your lunch and the options are disgusting, unappetizing, neutral, tasty, and delicious. Although we have words and not numbers, it is obvious that these preferences are ordered from negative to positive. Thus, the data is qualitative ordinal. Okay, so what about quantitative variables? Well, as you may have guessed by now, they are split into two groups, interval and ratio. Intervals and ratios are both represented by numbers, but have one major difference. Ratios have a true zero, and intervals don't. For example, length is a ratio variable. You all know that 0 inches or 0 feet means no length. With temperature, however, we have a different story. It is usually an interval variable. Let me explain. Usually, it is expressed in Celsius or Fahrenheit. They are both interval variables. 0 degrees Celsius or 0 degrees Fahrenheit don't mean anything, as the absolute zero temperature is actually negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. However, we can easily say that 80 degrees Fahrenheit is less than 100 degrees Fahrenheit. In the case of interval variables, the difference is meaningful, but the zero is not. Continuing this temperature example, there is another scale, kelvins. According to it, the absolute minimum temperature is 0 degrees Kelvin. Therefore, if the degrees are stated in kelvins, the variable will be a ratio. So, numbers like 2, 3, 10, 10.5, pi, etc. can be both an interval or a ratio measurement, but you have to be careful with the context you are using them in.
For more videos like this one, please subscribe.
So when we go about measuring behavior, the tool that we use to measure that behavior must be two things. It must be reliable and it must be valid. So the tool that we use to measure a behavior, it could be a scale, it could be open-ended questions, it could be a test, it could be a piece of physical equipment, like an fMRI machine, for example. But whatever tool it is that we're using to measure the behavior, the attitude, the opinion, it has to be reliable and valid. So we're going to start by talking about reliability in this slide, and then we'll talk about validity coming up. So reliability refers to how consistent your tool is. Are the measures repeatable with this tool? Does it measure the same way every single time it measures? And this isn't meaning at all that it's measuring correctly. It just means, is it reliable? Can I rely on it to measure consistently, to measure the same way it measures with every single person? So, for example, let's say I have this scale, and no matter who stands on the scale, it says that that person weighs 1,000 pounds. The question is that measure reliable? And the answer is yes. It is measuring the exact same way every single time. Is it correct? No, it's not correct. But no matter who stands on it, it collects their weight and it reports their weight the same every single time. It's 1,000. And so we want our measures to be reliable and valid. But in this case, we're just learning about reliability. So how can you test if your measures are reliable? There's a couple different ways you can do that. And so you can test, retest, and this is when you test a group now on whatever it is that you want to measure them on, whatever behavior or attitude, and then you can measure that group again 2 months later. And so if your measure is actually reliable, the scores that you got on the first measure should match the scores that you got on the second measure. So let's say that you wanted to measure someone's knowledge of tennis. And so you create this tool, this measurement tool called a test, and you write down a bunch of questions about tennis, and then you have the respondents take the test today. They take the test, they go home, you score the test, and then you have those same people come back 2 months later. You have them take that same test, and you collect their scores again. If your measure is reliable, their scores on the tennis test should be the same the second time they take it as the first time they take it. Maybe you give a little margin of error, like, if they miss one question that they got right on the first one, we'll still call that reliable in terms of our measurement. But they should be pretty close, if not exact. And then another way to test if your measures are reliable is called conducting what's called a split half. And a split half reliability test correlates half the items on a measure with the other half. And so let's say you have a questionnaire. What you would do is you would take half the questions on the questionnaire and put them into one group, and then you would take the other half of the questions and put them into another group. And these questions have been divided up into these groups completely randomly. And all the questions are about the same thing. So let's say that this is a questionnaire to see if someone is an introvert, for example. So you have your questionnaire of 50 questions, and then you randomly put 25 in one group and you put 25 in the other group. And then you give this introvert questionnaire in its entirety to a sample of people. Everybody takes a survey, they answer all 50 questions, and then they give it back to you. So then you take the responses to the 25 questions that you put kind of into the first group, and you take the responses to the questions that you had put in that other group, and you correlate the responses between those two groups. If your measure is reliable, you should have a strong positively correlated result after you run your correlation test. And the reason for this is because if the person is responding on the group 1 25 questions as an introvert, then the questions on group 2 should also show that person as responding as an introvert. If you're measuring them for introversion, and on the first 25 questions that you gave to them, they said that they were an introvert, and on the next 25 questions you gave to them, they said they weren't an introvert, you would not have a reliable measure. And then the last way to see if your test is reliable, or your survey, your questionnaire is reliable, is to run what's called a Cronbach's alpha. So a Cronbach's alpha takes the average of all possible split half estimates. So imagine that we compute that one split half reliability on introversion that we just talked about. And then what we do is randomly divide the items into another set of split halves. And we recompute this split half reliability. And then we divide them again and do another split half reliability. And we keep dividing them until we've gotten to all possible combinations of division. So we've separated that 50-point questionnaire into these groups of 25 every which way possible. Once we have gone through all of that and we keep computing these split half reliabilities, we have completed what's called a Cronbach's alpha. So a Cronbach's alpha is just taking these split half estimates and doing them over and over again until we get through all possible combinations of the items being in these two groups. I think it's a little difficult to understand without some type of visualization. So let's check out this video on reliability that explains these concepts like Cronbach's alpha and split half in a little more detail. Okay, so as promised, we're now going to talk about validity in measurement. And so a valid measure is one that measures what it says it's going to measure. And validity, or an absence of validity, is one of the major reasons in my class that students are not able to reject the null hypothesis and support their own hypothesis. And so it's very important that the measures we create, our surveys, our questionnaires, are valid, that they are actually measuring the variables that we are attempting to measure and nothing else. And so there are different types of validity, the first of which is called face validity. And this is the most superficial type of validity. It's just concerned with how a measure or procedure appears. Does it seem like it's a reasonable way to gain the information the researchers are attempting to obtain? Does it seem well designed? Does it seem as though it will work reliably? In other words, it's just kind of determining validity depending on whether or not the measure looks good, which is really not a safe way to go about making sure your measures are valid. We do want our measures to look good. In other words, our questionnaires should look, professional and stuff so that people take our questionnaires seriously. However, face validity can cause us to kind of assume that a measure is valid when it isn't. And to illustrate this, I'm going to tell you a story of a rock group called Van Halen, who would often put in their rider that they wanted only, I think it was brown M&Ms. And so a lot of people just assumed that they did this because they thought it would be fun to kind of torture the venues or laugh at their tour manager who had to sit there and pick out all of the other colored M&Ms that weren't brown. And so that hypothesis is the hypothesis that arose kind of out of assumptions. It is the hypothesis that sounds good on its face. So basically, that hypothesis has a lot of face validity. However, when you look deeper into that situation with Van Halen, the real reason that they did that was pretty smart. They had a lot of like pyrotechnics and flying and all kinds of crazy stuff in their concerts. And so they wanted to make sure that the venues were really reading those riders carefully so that they were maintaining all of the safety requirements and safety guidelines that they required so that no one at Van Halen would get hurt and no one at the venue would get hurt. And so the way that they verified that the venue had really read through their entire rider was if they got there to the venue and they went into the dressing room and they didn't see only brown M&Ms in the bowl. That meant that the venue had not carefully read through that rider, because then they would have noticed that odd request and they would have done that thing. So they were using the M&Ms from the writer not as a way to torture people, like that hypothesis kind of looks like on its face, but instead they were doing the M&M thing as a way to ensure their safety. So when it comes to face validity, just because our measure looks really good doesn't necessarily mean that it is measuring what we want it to measure, so we have to be careful of that. And then construct validity is referring to the operational definition of the variable. And this is the type of validity that my students sometimes struggle with and then have it impact the results of their study, meaning that they're not able to reject the HO and support their hypothesis. So if we want to measure depression, we need to make sure that we know the symptoms of depression and we ask specifically about those symptoms. We don't want to just kind of guess what the symptoms are and then ask questions about that. We want to make sure that when we're writing our questionnaire, the questions that we're asking are really on point with the behavior, the attitude, the opinion that we are studying. So if we wanted to measure depression and we asked the person how tall they were, we would have no construct validity in that measurement. I had a student one time that wanted to measure how far people commuted to school. And the way they measured that was by asking people if they had listened to podcasts while they were driving. And so they felt like a podcast is generally long, maybe it's an hour in length or longer. And so if you're listening to a podcast while you're driving, then you are obviously commuting far. but they didn't ask questions about the length of the podcast or anything like that. So just asking if someone listens to podcasts as a way of measuring how far they have to drive is really not going to give us construct validity. So we would need to ask that person just very straightforward, direct questions like, how many miles does it take to get from your home to your school? And that would be a measure that had construct validity. And then content validity is the degree that a measure assesses all dimensions of a construct. So if you wanted to study student satisfaction, but you only asked people how they felt about the library, then you would not have achieved content validity. You could have also asked about parking, student health services, the counselors, pricing, tuition, and how the instructors were, how easy it was to get classes, all of that. So when we are measuring our variables, we need to make sure that we're measuring all aspects of that variable, and not just like, one small portion of the variable. And then there is criterion validity, and this is the degree that a measure correlates with another measure of the same kind. So for example, if IQ and school performance both measure intelligence, then they should be positively correlated. Okay, so you have heard me use all of these words in this lecture today: tests and scales. Oh, maybe I didn't say inventories, and now I'm saying inventories. And so these terms are all used to describe measures. A test, to be clear, are procedures used to measure a variable. Like the marshmallow test is a very famous test, so I'll be showing you that in a second. And then a scale measures a specific psychological characteristic. For example, an intelligence scale will give you an overall score, but then it will also give you scores based on subscales. So your verbal intelligence, your musical intelligence, your picture intelligence, and so on and so forth. And then we have inventories, which describe personality or interests. So with inventories, you're not signed an overall personality score, for example, but instead you are given subscale scores. So if you were to take the Big Five personality assessment, or the 5-factor model, is what that assessment is based off of, what it will tell you is the subscales scores for your personality. So your score on extroversion, your score on openness, open-mindedness, your score on conscientiousness, your score on agreeableness, your score on neuroticism. But it's not going to give you one overall personality score, because that doesn't make sense. All right, so I want to leave you with the marshmallow test. The marshmallow test is one of my favorite tests in psychological research because it's super cute. So what they do is the researchers give a kid a marshmallow, and then they tell the kid, I'm going to leave the room. I'm going to come back in a couple minutes. If that marshmallow is still here, I'll give you a second marshmallow, and then you can eat both. And so they are testing for impulsivity to see if these kids are not going to be able to wait for the second marshmallow, or if they will not be impulsive and be able to wait. So this is an example of a test. Specifically, this is the marshmallow test.
Okay, sit in that chair. All right, here's the deal. Marshmallow for you. You can either wait, and I'll give you another one if you wait, or you can eat it now. When I come back, I'll give you another one, so then you'll have two. But stay in here and stay in the chair till I come back, okay? All right. I'm gonna go do something and then I'll come back.
It smells yummy. It smells really good.
So it's up to you. You can have it now or you can wait. Okay? I'll be back. Stay in the chair, okay? Okay. All right, so I'm gonna leave and then I'll come back, okay? So you can either eat it right now or you can wait. Either way, okay? Okay. How'd you do? Did you do good? You did?
Yeah.
You wanted to eat it, didn't you? Yeah. So did I tell you to give you another one? Okay, now you can have both. You need them.
And that is it for chapter 5. Thank you for listening all the way till the end. Have a great day. We'll talk to you on the next one.